Hello everyone. Today I'm going to talk about radiation heat exchange between two disks. And this problem was presented to me as part of the interview process with the aerospace company, and I thought to share it with you and teach and learn something new. So the problem was that they had two parallel coaxial disks which are floating in deep space, and each disk is 1 meter in diameter and the disks are spaced 5 meters apart. One of the disks is a black body at a fixed temperature of 5500 Kelvin. The other disk is painted with a high temperature high temperature white paint on both sides. Estimate the temperature of the white paint disk. List your assumptions and explain your reasoning. So in this slide, I'm gonna presenting the geometry of the problem, and please note that this geometry is not in scale because the distance of the disk is 5 meter, and it should be way larger than this, but I think it's good for our problem. And please note that I represent the space by this dotted line. And I'm going to use the electric circuit analogy to solve this problem. And if you don't know about this technique, please search it on YouTube or go to heat transfer books. So for the black body, I assume that the emissivity is 1, and for the white painted disc, I assume the emissivity is 0.05. Also, I assume that this thickness is negligible, and as a result, there is no temperature gradient, and the temperature of both sides of this disk is the same. So starting from the black disk, we got this view factor F12, and then we reach to the second disk, and this is representing the heat transfer from that side, and we reach to the other side of the disk, and this represents the heat transfer there, and also there is a heat exchange between this side and the space, and which is represented by this equation. And from this set of equations, we know everything except F12 and F3s. But from the geometry, we can tell that F3s is 1 because all of the heat radiated from this surface is reaching to the space. So this is equal to 1. For F12, fortunately, there are sets of equations based on the geometry. And since we have the diameter of the both disks which is equal, and we have the h, which is the distance of these two disks, if we plug them into this equation, we get F12 as 0.01, which is kind of very small, but I guess the reason is because they are spaced far away from each other. So knowing this, we plug them into this equation. Now we have everything except the temperature of the disk 2. So we use energy balance, and basically it means that the input heat is equal to output heat. And when we present them in a mathematical formula, this is what we get. This represents Q1 and this represents Q2. The summation of these two formulas is 0, and after inserting the related values and simplification, we get to this simple equation. And since we know that the energy of the black body is equal to this equation, so when we calculate this value, the temperature of second disk or white painted disk is 3387 Kelvin, which is kind of making sense because it should be lower than the hotter disk. Also, I was curious to see if we use black body as a white painted body, what's going to happen to the temperature. And interestingly, even the temperature becomes lower, and you wonder why. The reason is the black body is an excellent emitter. Also, it's an excellent absorber. So because of that, I guess when you put the numbers in that equation, this is what you get. And you shouldn't always assume that the black body is always hotter than the other colors when you're dealing with radiation problems. So that was it for today. Thanks for watching this video, and please subscribe.